Hello everyone, welcome to the video walkthrough solution of Jan 23 Unit 2. Let's look at the very first question. The graph shows how current I varies with potential difference V for an electrical component. When you look at the graph, you see it's a straight line through the origin. Whether it's an IV graph or a VI graph, a straight line to the origin implies resistance is constant, and resistance remains constant when the temperature remains constant. So my answer is C, a resistor at constant temperature. Monochromatic light travels through air and enters a glass block. It means it undergoes refraction. So when refraction occurs, the speed changes, wavelength changes, but the frequency does not change because the frequency of a wave depends on the source. A ray of light approaches a boundary between air and glass as shown. Angle of incidence is I. Question is, which of the following statements about total internal reflection is correct for a ray of light at this boundary? Look at this. Light is traveling from air to glass, as in from a less dense to a more dense medium. And we all know for total internal reflection to occur, light must always be traveling from a more dense to a less dense medium. If light is traveling from a less dense to a more dense medium, whatever happens, total internal reflection cannot occur. So answer is TIR cannot take place. So the equation n lambda equals d sine theta can be used to determine the wavelength of laser light that has passed through diffraction grating. Which of the following is represented by d in the equation? Let's take a look at two diffraction gratings. So of course I cannot draw 100 lines in 1 millimeter, but of course this is something not to scale. This is a few lines in maybe some millimeter, and since it has got more number of lines, so more lines per millimeter. So the distance between two lines is what you call D. This is D. Is the distance between adjacent lines on the diffraction grating. A bat is an animal that locates objects using pulse echo technique. Focus on the echo bit, right? A bat emits a pulse of sound wave that travels to an object. The bat detects the reflected pulse 6 milliseconds later. Speed of the sound is 340 meter per second. Which of the following gives the distance in meter of the object from the bat? So the moment you look at echo, the equation that should pop up in your head is V equals 2D by T. So if you make D the subject of the equation, D should be V times T divided by 2. So if you have 6 millisecond, 6 divided by 2 is 3. And since it's millisecond, it's times 10 to the power minus 3 divided by 1000. That's what makes my answer C. So the V is 340 and T by 2 is 0.003. A light-dependent resistor is connected in a circuit as shown. The intensity of light incident on the light-dependent resistor decreases. We all know if the intensity decreases, the resistance of the LDR increases. And since they're connected in series, if the resistance of one component increases, the voltage across it also increases. So if the voltage across the LDR increases, since they're connected in series and the total voltage must remain constant, the voltage across the fixed resistor must decrease. Number one. Number two is, if the resistance of the LDR increases, the resistance of the entire circuit also increases. So that decreases the current. So the current decreases and the voltage decreases. So my answer is A. Ammeter reading decreases and the voltmeter reading also decreases. The diagram shows some of the energy levels in an atom. Electrons in this atom are excited from the ground state to the energy level N3. So the diagram shows some of the energy levels in an atom. Electrons in this atom are excited from the ground state to the energy level 3. How many different frequencies of radiation can be emitted? Focus on the word emitted. So the electron has already been excited to level 3, N3. So how many ways it can drop down? It can directly drop down from N3 to N2. So this will emit a photon. It can drop down from N2 to N1. So this will emit another photon. And it can directly drop down from N3 to N1. So this produces a photon of one frequency, this of the other, and this of the third kind. So there are three different frequencies of photon that can be emitted. So answer is 3. When longitudinal wave passes through a material, compressions and rarefactions are formed. Which of the following statements is correct? So it's better if I show you a diagram like this. Look at this. Here you have a rarefaction and here you have a compression. So, okay, it's better if I show you from here. So here the particles are undisplaced, and when a longitudinal wave passes, you'll see all the particles around the compression move towards the compression, and all the particles around the rarefaction move away from the rarefaction. But at the compression and at the rarefaction, the displacement is 0. Displacement is always 0 at both compression and rarefaction. But at the compression, the particles are bunched up, so the pressure increases. And at the rarefaction, particles are spread out, so the pressure decreases. So that makes the answer D. Rarefactions are points where pressure is a minimum. So let's look at the other options as well. Compressions are points where displacement of particles is maximum. No, at both compression and rarefaction, this is what we just saw here. At both compression and rarefaction, displacement is minimum or 0. Compressions are where point where pressure is minimum. No, compressions are where pressure is maximum because particles are bunched up here. Rarefactions were points where displacement of particles is the minimum. Displacement is not minimum, displacement is 0, not just minimum. Next question. A lamp is connected in the circuit as shown. The cell has negligible internal resistance. In 30 seconds, the charge passing point P is 0.4 coulomb. Which of the following gives the energy in joules transferred by the cell during this time? So what do I have here? I have the charge, I have the voltage. So electrical energy is given by QV. So charge times voltage gives you the electrical energy. So 1.5 times 0.4, my answer is B. Question 10 says, which of the following is not a correct statement about stationary waves? Answer is C. The distance between adjacent nodes is equal to one wavelength. The question says not. Be careful about this. So if I draw a standing wave or stationary wave, this is what a standing wave looks like. So here I have my nodes. So if you see, the distance between two adjacent nodes is not equal to the wavelength. It's actually wavelength by 2, lambda by 2. So this is a wrong statement. Distance between adjacent nodes is equal to one wavelength. No, it's half of a wavelength.